Hey Matt, I stumbled across a comment you made about making an example for a dynamically updatable spring simulation in Flutter. Just wondering if you could let me know how I could accomplish something like this. So, a simulation of a spring, except while you're simulating the spring, you want to also be able to change the anchor position of the spring so that the spring is constantly springing to different positions over time. Well, that sounds like a challenge. That sounds like a Flutter challenge. The first thing that we want to do whenever we try to solve a new problem in Flutter is to begin by figuring out what Flutter offers us that might already solve the problem. In this case, we're interested in some kind of spring capability. So we'll go to the main Flutter website and we'll search for something related to springs. We'll get really excited when we make our way to the spring simulation class. That sure sounds like it's relevant to what we're doing. And we'll also find the spring description class. Now, a spring description essentially determines how springy your spring is. It just describes the characteristics of your spring. So let's go back to spring simulation. In an ideal world, we would already be done, right? We wanted to simulate some kind of spring. Here's a spring simulation. Problem solved. Until we go look at what a spring simulation actually tells us. We look over here in the methods, and we see this method called X. You can kind of think of it like a property. You just happen to invoke it with an amount of time. But X is the distance that the particle, let's say, currently occupies from the anchor of the spring. Because there's the anchor point for a spring, then there's where the actual item is, and it springs back and forth. X is the distance between the anchor point and whatever particle is springing. The problem is we don't see a Y value. We can get distance along one axis, but that's the only distance that we can get. We also have dx, that's essentially the velocity or the speed, depending on how you interpret it, but where's our second dimension? This then begs the question why spring simulation was created. Let's remember or think about why this class exists. Flutter is primarily designed to implement pretty traditional mobile web and desktop user interfaces. The reason that spring simulation exists is because when it comes to list views, whether it's vertical or horizontal or grid views, you might have a spring effect when you're scrolling. You over scroll and then it kind of springs back up into place. Springs have a role to play in scrolling, but traditional scrolling only happens along one dimension. Again, it might be vertical or it might be horizontal, but odds are if you're panning in 2 dimensions, you probably don't want a spring involved. But even if you do, panning in 2 dimensions is pretty uncommon. So whatever set of problems the Flutter team set out to solve when they created spring simulation, it obviously didn't include 2-dimensional springs, but 2-dimensional springs is the problem that we are here to solve. And not just 2-dimensional springs, but 2-dimensional springs where the anchor point can move and change over time. Now that we know what Flutter offers us, it's time for us to figure out how we might use what Flutter offers us to solve the actual problem that we need to solve. So let's jump into that now. And the first thing that we're going to do, I already have this app running. It paints a black screen essentially. Other than that, it's empty. But the first thing that we're going to do is set up a user interface that's conducive to exploring and solving our problem. But we're going to have a little bit of fun with it. We're going to theme this a little bit because the effect that we want with springs, I find that it reminds me a little bit of Spider-Man. Like if Spider-Man were jumping between locations on a skyscraper. And so I've actually brought some assets in here that will allow us to build this little experimental UI where we can then figure out how to create these two-dimensional dynamic springs. So let's start by kind of creating our test bed. Let's create this little UI that facilitates our experimentation. So the first thing, we're going to want to stack, I want a background, okay, that takes up the whole screen, and then I want a little circular draggable thing at the center of the screen. This is what we're going to work with. That requires a stack. If we want the background taking up the screen and then something sitting on top, that's what we use a stack for in Flutter. So let's begin with a stack. And of course, we need to actually provide or put something in the stack to render. Let's go ahead and put the image in there of the background to get us started. So let's go with a sized box that we will expand to take up all the available space. And then I have a local asset that I'll bring in. It's at assets skyscraper window.jpg. And then we want this to cover, we want the image to cover all available space. So we'll set the fit to cover. Actually, I'll show that and then we'll adjust the color a little bit of the image. And this should have been plural. And now we can see that we have an image that takes up all available space. Now, one quick thing, notice that we can't really see the status bar here. It doesn't really matter for our experimentation, but in case you're ever wondering, how do we go from a dark status bar to a light status bar when we don't have an app bar? Because the app bar does that for us, but in this case, we don't have an app bar. Well, we can surround our stack with what is called an annotated region. This allows you to control various values from parts of your widget tree. The value that we want to set here is system UI overlay style.light. And when I save that, notice that our status bar becomes light. It's still kind of tough to see, but we're going to fix that right now. We're going to darken this background a little bit so that it contrasts more with our foreground. To do that, we can come in and give the image a color. And in this case, we'll go with black with opacity of maybe 0.6. And then that makes the whole thing black, so that's no good. But we can then set the color blend mode and set that to blend mode.multiply, which essentially darkens the image in this case. And so we save that. Now you can still see the skyscraper, but it's much darker, and we can see clearly the status bar text contrasting with that background. So this is the background that we want. Again, I'm thinking in this fun space of a kind of caricature of Spider-Man slinging his web around the skyscraper. Let's get the little Spider-Man icon in there. But first, let's go ahead and refactor here. Let's take this sized box, or our entire background image. Let's cut that out, and we're going to create a function called build background. And let's just return it from there so we don't pollute our larger tree with details that don't matter. We save, everything remains the same, and now we have a much simpler widget tree. But now again, let's get this little Spider-Man style icon in here. To do that, let's make it 64 by 64. And then we want an image within those constraints. So we'll give the sized box a child. We'll go with an asset that I have called spiderman.png, PNG to get transparency. And also we want this to be aligned to the center. A few different ways you could accomplish this. We're going to go with the align widget, and let's save that. And there we go. Now we have this little Spider-Man icon looking thing in here. Our goal is to be able to drag this thing around the screen, because if we're going to play with springs, we need to first be able to drag and move the thing that springs around. Then we're going to get a single dimension spring working, which allows us to explore what Flutter has to offer. And then we're going to figure out how to make it two-dimensional. And then after we make it two-dimensional, we're going to figure out how to actually change the location of the spring anchor. But first things first, we need to be able to actually drag this thing around. Once again, to simplify our widget tree before we get into dragging, let's go ahead and extract this sized box. and we'll just invoke a method that we will create called build Spider-Man. Come down here, build Spider-Man, return what we just cut out, save, and we're all good. And then the question becomes, how do we actually set up dragging for this system? Whenever we want to deal with dragging, it's going to involve a gesture detector. And we want a gesture detector to wrap around the thing that we want to drag. This build Spider-Man right here is what we want to drag. So let's surround that with a gesture detector. Now that's not going to change anything visually because we haven't altered our state in any way, but I'm going to introduce a local variable that will allow us to change what we see. And that's going to be what I call a thumb offset. In UI elements where the user drags things with his or her thumb, often the thing that you drag is referred to as a thumb. For example, if you go look at sliders, the part that you move on a slider is called a thumb. For lack of a better term, we're going to kind of refer to this little Spider-Man thing as a thumb, and it may have some kind of offset. That's how dragging works. When you drag it, you change the offset. So let's come down here to this Spider-Man, the build Spider-Man call. We will wrap it with a widget, and that will be a transform.translate, which is going to allow us to apply an offset. It's broken because I haven't actually provided the offset, but we're going to provide the thumb offset. Now still nothing has changed, and that's because our thumb offset is 0. But if we listen for drag events and then we update our offset, we can actually move the thumb, move the little Spider-Man icon as we drag. To do that, we want to listen to the on-pan update property of the gesture detector. And we will define a local method called on-pan update. So on-pan update, and we're going to get drag update details. And then what we're going to do is call set state with thumb offset. All we're going to deal with first is a vertical spring, right? Because what Flutter gives us out of the box is just a single dimension of spring. So let's figure out how to do that, then we'll worry about 2 dimensions. But for that reason, we're not going to allow dragging in 2 dimensions. We're just going to allow vertical dragging so that then we can build a vertical spring. So we're not going to mess with the X value at all, but we will take the movement of the user's finger and we will grab the difference in Y and we will add it to the thumb offset. We'll save that. Nothing has changed yet, but notice that now we can drag. And that's because every frame that the finger or cursor moves, that delta is added to the offset. And notice that if I drop it somewhere else, it stays there. Although okay, so the gesture detector, you'll notice I can't drag it now. And that's because I put the gesture detector outside the translate instead of inside. So I can come here and I can press Option Enter, and I can swap gesture detector with its child, which is the translate widget. Let's save that. And now I can slide again. The gesture detector is what keeps track of the tappable or clickable area. So we need to make sure that the tappable area is moved along with the image. But now we've got that. Now the other kind of thematic detail that I'd like to draw a thin line between the anchor of the spring and the part that we're dragging so that we can easily see where it's being pulled and how it overshoots and things like that. And visually, it would be neat if it kind of just looks like a little spider web, which really just means a thin gray line. To accomplish that, we're going to use a custom painter. So let's go ahead and create the painter for it. We'll call it a web painter, and it's going to extend custom painter. And we don't need to worry about repainting here. But we need two pieces of information to actually paint this little hypothetical web. One thing that we need is the spring offset. This is the distance from the anchor of the spring to the particle that's actually springing. That's the line that we're going to draw. And then we're going to need the spring paint, which can always be the same. So we can just define that here. The color we will set to gray. We will go with a stroke width of 2. And we're not going to fill a shape with any paint. We're just going to use a painting style dot stroke. So that's fine for the paint, but we do need a constructor that takes in the spring offset. And we'll offer a default value, although one should always be provided. All right, and then what do we actually want to paint? We know, at least at this moment, we know that the anchor position is always in the center of the screen, and we know that this custom painter that we're creating is going to take up all available space. So we will grab the center of the available space by saying size.center. Offset 0 just means assume that the size starts in the upper left corner, which it does. So we grab the center of the available space, and then we're just going to draw a line. We're going to draw from the center position to the center plus that offset, the drag offset that we defined in our widget tree, and we're going to use the spring paint. So now we just need to make use of this web painter up in our widget tree. And thinking about it for a second, I think I might actually prefer the gesture detector to be above the stack. I think I'd prefer, like, no matter where we start dragging on the screen, I think I'd like that drag to push the thumb. I just think it's easier to manipulate, easier to experiment. So let's go ahead and make that change real quick before we bring in the custom painter. Let's bring the gesture detector up here. I'm going to come grab the on pan update, and I'm going to remove the use of it down there. Let's save that. And now notice that no matter where I drag from, it moves up and down. I think that's just going to be easier for experimentation, but it's totally up to you. Now here's the background that paints the skyscraper. Here's the thumb, the Spider-Man thumb on top of it. Let's come right in here in between and use a custom paint widget whose painter is a web painter and whose spring offset is equal to the thumb offset. And let's also, because nothing causes the custom paint to be a certain size, it doesn't have any children, let's explicitly tell the custom paint to be as large as it can. Let's save that. And now notice over here that we have this line. You see that? It's kind of like a little web, right? This allows us to see where the anchor position is and where the thumb is, which means that in the next step, what we can do is figure out how to set up a Flutter spring simulation to give us, a vertical spring. And then once that's working, we'll figure out how to also add a horizontal component to it as well. But again, first things first, let's go figure out how to create a vertical spring. We want to create a vertical spring, so where do we begin? I guess we'll begin with a spring description. We're going to need to know what kind of spring or how springy our spring will be, and that's accomplished with a spring description. So in our state object, let's declare a spring description, which is an instance of spring description. One of the most difficult things to do when it comes to Flutter springs is to figure out what the parameters of this thing should be, because they're all related. There's a mass that you can assign to it, a stiffness, and a damping factor. And again, the problem is that each of these properties is essentially relative to the other two. You can think of mass in terms of kilograms or pounds or some made up unit. Stiffness is a unitless value, and I believe damping is as well. So I'm going to go with some numbers that I know give us a reasonable spring, but you may have to play with this for hours to get exactly the values or exactly the spring behavior that you want. In our case, a mass of 1, a stiffness of 500, and a damping of 15 is going to give us a reasonable spring effect. But with the spring description, what's the next step? How do we start getting some notion of a spring in here? Well, first, let's think about when the springing should actually occur. If I drag this thing up, I don't want a spring getting in the way right now. I want to be able to drag, but when I release, that's when I want a spring to take over. It's also the case that when I start dragging again, if a spring is still affecting our little Spider-Man thumb, I want that spring to stop affecting it. So when I start dragging, we want to stop a spring. And when I release and I stop dragging, we want to start a spring. So this at least gives us a jumping off point. We know that we're going to want an on pan, I think start. We can call it whatever we want, but I think Flutter typically refers to it as on pan start, which has drag start details that comes in. We'll come back and deal with this in a moment. And then we also want an on pan end with drag end details. We'll deal with that in a moment. It's also not going to affect us here because our drag area takes up the entire screen, but there's also a possibility that a pan is canceled. This is when the user drags outside of a draggable area, or there may be multiple ways that the user can take actions that essentially stop a pan that momentarily had started. And the reason this is important is because if you're going to alter the state of your system, if you're going to alter the state of your system when the dragging ends, you also need to pay attention to when it's canceled, because typically you want to do the exact same thing for both of these scenarios. With these methods declared, we're going to come back down to this gesture detector and we're going to hook them up. So on pan start, we will call our on pan start method. Again, this method does not need to be the same name. I just do that so that I remember why it's invoked. Then on pan end, we will send to on pan end, and on pan cancel, we will send to on pan cancel. So I told you that when we start dragging, we want to make sure there's no spring going on. So we want some kind of behavior like end spring. Doesn't exist yet, but we want to create it. When we stop dragging, we want to start spring. Now, actually, this is one of the rare cases where what we do on the end of a pan is not what we want to do on cancel. We've actually just discovered that we don't need a cancel, because if on pan cancel is invoked, it means that the entire drag didn't really happen, which means we should not be starting a spring simulation. We can actually go ahead and delete on pan cancel, and we can get rid of it from the gesture detector. So in our case, in this particular case, doing something when the pan begins and doing something when the pan ends, that is sufficient. But we still need to implement those things that we want to do. We still need to do something for start spring, and we still need to do something for end spring. We don't know what that is yet. So now what's the next thing that we need to care about? If we're going to have a spring description, then it must be the case that we are also going to have a spring simulation. But we need to figure out how to use this thing. We know that in this start spring call, we want to somehow start a spring simulation. So it's a pretty safe bet that right here in start spring, we want to take that spring simulation and instantiate a new one. It wants a spring description, which we've got. Then it wants a start value, and end value, and a velocity. These values are kind of up to us in the sense that where it starts and where it ends depends on our user interface. oops, this should be, spring description. We are basing all of our UI right now off of an offset. We begin at the center of the screen, and then we add some offset up and down. Therefore, the end position, and remember, this is just vertical. This is one axis. The end value for our spring is going to be 0. Because when we spring back into place, we want that offset to be 0 at the center of the screen. When the offset is 0, we will be back at the center. And for now, let's not worry about velocity. This just brings us to the starting position. Where does the spring simulation begin? How far from the anchor is the spring when it begins? That is going to be equal to thumb offset dy, because we're dragging in the vertical. We now have a spring simulation. But what do we do with it? A spring simulation, if we recall, has that x function. We can call spring simulation.x, but it takes in a unit of time. If we go look at the definition, I guess the documentation isn't very good right here for this method, but this is the total elapsed time. This is the total elapsed time that has gone by during the spring simulation. At the very beginning, the value is 0. 1 second later, it's 1 second. 2 seconds later, it's 2 seconds. In other words, we tell the spring simulation 2 seconds have gone by. Tell us what our position is after 2 seconds, and then after 3 seconds, and after 4 seconds. But this means that we need to know about the passage of time. The spring simulation is useless to us if we don't know how much time has gone by. And not only that, but we need to actually essentially refresh our user interface as time goes by. How do we do that? In the case, if we were using traditional animations, we would use an animation controller, and that would tell us as time goes by. Or sometimes we use delayed futures, or sometimes we might use timers. These are all ways in Dart/Flutter that we can do things over time. But in our case, we're going to use a ticker. A ticker is what animations use internally to track time. We're going to avoid the whole animation controller API surface, and we're just going to manage our own ticker. So we're going to add a ticker property. And it looks like we need to import the scheduler for that. And I guess I already had this declared, but in case you didn't catch it, we need a single ticker provider state mixin, which is a mouthful. What that means is that we're adding the ability to our state object here to give us a ticker. Now, where do we want that ticker? We want to start ticking in start spring. So we'll say ticker equals create ticker. This is a method that's available to us because of the mixin that we added. Create ticker, and then in a minute we will define on tick. However, our mixin is the single ticker provider state mixin. We can only create one ticker. It doesn't have to be that way. There's a different mixin that allows you to create multiple tickers, but we don't need multiple tickers. We just need one. We just need to be a little careful here. We need to say only if the ticker is null are we going to create it. But then after we create it, or if it was already created, we're going to say ticker.start, and then it starts ticking. Every single frame, our function here is going to be called, allowing us to do something on every single frame. Let's define that. Remember a moment ago that I mentioned that the spring simulation cares about, we have to tell it the elapsed time during the spring simulation. That's exactly what the ticker system gives us. Every frame it ticks and it tells us here's how much time has passed since you started the ticker, which is exactly what we need for the spring simulation. We can say spring simulation.x. Now here's another interesting thing. X, the function x, takes a double, not a duration. You might be tempted to say elapsed time dot in seconds, because actually this x value, we want to interpret it in seconds. The problem is when you say in seconds, what we get back is an integer. It's not like 3.5 seconds. It's either 3 seconds or it's 4 seconds. And that's no good because we are going to run this function like every 16 milliseconds. So instead, what we need to do is we need to calculate what I will call the elapsed seconds fraction, which is equal to elapsed time in milliseconds divided by 1,000. Now, if 3,500 milliseconds has gone by, that's 3.5 seconds, and the elapsed seconds fraction will be 3.5. Not just 3 or 4, but 3.5. That's the value that we want to pass in here. And the way we want to use this value is that we want the thumb offset to be equal to 0 on the x-axis and apply this distance on the y-axis. If the spring says, okay, at this moment in time, you should be 200 pixels away from the anchor, then this value right here is 200 pixels. Then we are down here. We're 200 pixels down. Maybe it says negative 100 pixels, and then we're up here. The x value remains 0, but the y value is whatever the spring tells us it should be. And notice how funny it is that we're actually using the x value of the spring and we're setting our y value. This is just an unfortunate consequence of springs being one-dimensional. But point is, don't get confused by it. The second value here is the y value of our offset, but we're invoking the x value of the spring simulation. Now, it's also possible that when the ticker calls us back, that the spring simulation is done. And if the spring simulation is done, we want to end it. So we can say if spring simulation is done. Now, once again, we have to pass in the amount of time. We're always passing in the amount of time. The simulation does not track that. But if it's done, then we want to say end spring, which is still just a to-do. What is it that we want to do in end spring? We'll just say if spring ticker is not equal to null, then spring ticker stop. Excuse me, just ticker is what we called it. We just tell the ticker to stop ticking. We do that when the simulation is done, and we do that when we first begin dragging in case there's already a spring going on. So again, we will start dragging, we'll move our thumb based on thumb offset, then we stop dragging. When we stop dragging, we start a spring simulation. That comes down here. First thing we do is instantiate a spring simulation. We create our ticker if it doesn't already exist because we need to be notified every single frame that goes by. And then we start our ticker. Theoretically, this should move the thumb. Let's do a hot restart and see what happens. So let's drag it up and then let go. Nothing happened. And one big reason why, if you were paying attention, is notice that we changed the thumb offset, but what we don't do is call set state. Notice, so let's see, pull it down. Notice that it springs back. Pull it up, springs back. So while we drag, no spring is allowed. When I release, it starts the spring. And that's because this on tick, it's called every single frame. That's why we have this ticker. Every single frame, it says some time went by, some time went by, some time went by. And we take that time and we tell the spring simulation, where are you now? It's like that Sprint guy or whatever phone service he works for these days. Where are you now? Where are you now? Where are you now? The spring simulation tells us at every frame where we should be according to spring physics, which is what spring simulation actually does for us. It calculates the spring physics. And then, of course, when the spring simulation is done, when the friction has caused the spring to kind of stop in place, is done becomes true, and we stop ticking. This is using the totally standard built-in one-dimensional spring simulation in Flutter. This is how some scrolling things are done in Flutter. We've now gotten that far. But now I want two-dimensional springs. I want to be able to drag this little icon anywhere on the screen and have it spring back to the center. We're going to figure out how to do that in the next step. Now let's get this spring working in 2 dimensions. And fortunately, that's not all that difficult because we can treat each dimension of a spring completely independently and still get the visual effect that we want. That's why it's not going to be very difficult. If somehow a 2-dimensional spring behaved fundamentally differently than a 1-dimensional, then we'd be in trouble. But really, if we want X and Y or vertical and horizontal springs, we can accomplish that by using 2 simultaneous spring simulations, one for vertical, one for horizontal, one for X, one for Y. So the first thing we're going to do is use a name that will be easier for us to keep track of. Instead of just a generic spring simulation, we're going to call this spring sim Y because we're going in the vertical. But we're also going to introduce a spring simulation called spring sim X. And we're just going to go down through our code and make adjustments where necessary to deal with the second axis. Let's see where it makes sense to make these changes. As we come down, one place is right here in on pan update. We're holding the X value to 0. We don't want to do that anymore. We want details.delta.dx, which of course is the same thing as getting rid of this entire offset and just saying details.delta. Now we're dragging in 2 dimensions. Remember, this whole thing is about dragging. Now we're dragging any direction we want, X and Y and whatever. At the end, we start a spring, that's fine. But now down here in start spring, here is our Y simulation. We also need an X simulation. So I'm just going to copy this, paste it right here, spring sim X instead of Y, thumb offset DX instead of DY. So now we have a simulation in the X direction and a simulation in the Y direction. We still only need 1 ticker because the whole point of the ticker is to tell us a frame was rendered, a frame was rendered, a frame was rendered. It doesn't matter how many dimensions of a spring we're dealing with, that's just 1 ticker. And we start that 1 ticker. Then, when we actually process a tick, we do need to make a change here. Notice that in our thumb offset, once again, like we had it before, we're holding X constant at 0, and we're using a spring simulation for Y. We're going to come right in here, and instead of 0 for the X, we're going to use our spring sim X, and we're also going to pass it the elapsed time to ask it where we should be. Then this line here needs to be updated. When the simulation is done, we want to end the spring, but these 2 simulations might end at different times because we might pull more in the Y direction than the X direction or vice versa. Therefore, we need to alter this line to ask if the X simulation is done and the Y simulation is done. We don't want to stop ticking until both simulations are done. Save that. And let's do a hot restart just to make sure everything is up to date. And first, we're going to test the drag. All right, notice that we can drag anywhere we want. And now let's release. Notice that it's springing in 2 dimensions. No matter which direction we go, we get a spring. The answer here was to use 2 spring simulations instead of 1. And the reason this works out is because the math of it operates, even the physics of it operates such that the 2 axes don't interfere with each other. In other words, an X and Y simulation is exactly equal to just an X simulation plus just a Y simulation. This is not true for all things in physics and all things in math. In fact, it's often not true, but it happens to be true for spring simulations, that by taking 2 independent simulations and just putting them together, it looks as if there's just one 2-dimensional simulation. So that's how we got to this answer right here. But now, for kind of the whole point of this exercise, we don't just want 2-dimensional springs like this. We want to be able to change the anchor point. The anchor point has always been at the center of the screen. Yes, we can drag wherever we want. Yes, we can get a spring effect from any position we want, but it always goes back to the center. We want to see if we can actually change the destination of the spring over time. That's going to introduce a few challenges for us, and that's what we're going to figure out how to do in the next step. To change our anchor position, we're going to need to really alter the way that we think about the origin of the anchor position. Up to this point, we've used this align widget, alignment center, which allows us to work with what we've called a thumb offset. It's not really a thumb position in terms of the screen coordinate system. It's just an offset from the center. But now that we want to be able to place the anchor point wherever we want, we can't really think about a center-centric coordinate system anymore. Instead, we need to recognize that the top left of the screen is the origin, 0, 0, and we need to consider the possibility that we place the anchor point at any XY position anywhere on the screen, which is to say that this align approach really isn't going to cut it anymore. Let's begin making some adjustments that will allow us to actually use any position on the screen as an anchor point. The first thing we're going to do is rename thumb offset. This, from here on out, this will no longer be an offset. It will actually be a position. And this is just a semantic difference. The type of it doesn't change, but instead of being a distance from the center, it's going to be a distance from the origin, which we often think of as a position. So we're going to call it thumb position. We're also going to add a new property, which is going to be anchor position, which for now we will just set to 0, although we'll probably come back and make this null, and I'll show you why in a moment. But for now, we'll set it to 0. The anchor position refers to the location on the screen where the spring is springing to. Like right now, that's the center. Right now, the center is that anchor position. Thanks to the align widget, we never needed to specify it explicitly, but now that we want to change its value, we do need to hold it as a variable and alter it. The reason I brought anchor position in right now is because we're going to pass it to the web painter. The web painter is the thing that paints the line from the thumb to the anchor. So the web painter needs to know where the anchor is. Let's go down to the web painter. Here's the web painter. We're going to add an offset called anchor offset. And in fact, let's also update both of these to be called position. Anchor position, spring position. And let's get rid of this default value because now that it's a global position, we don't even know what a decent default would be. We're going to require both of these. They both need to be passed in. Now that it's required, let's go up to where we invoke our constructor, which is right here. We're already passing in the spring position. Now we're going to pass in the anchor position. And remember, right now it's just 0. In Web Painter, we're going to draw a line. Previously center was the anchor position, right? We can just replace center with anchor position. And then spring position is no longer an offset, it's a true position. So we don't need to add anything to it. We just draw from the anchor to the spring position. And now we can get rid of the center calculation. Let's save that. Let's do a hot restart. And I was expecting this line to draw from the top left. So we'll need to figure out why that's not happening. Oh, it's because it's drawing from 0 to 0. Because the spring position is also 0. So for example, notice that as I drag, now we can see the line. The problem is we're still center aligning our thumb, and therefore all this distance, well, let's just go fix the problem. The problem begins right here. Our thumb is not placed at the spring or the thumb position. It is still beginning at the center. So let's just let's remove this align widget. And now notice that our thumb is way up here, which is where it should be now that we've changed the purpose of these different positions. Now we still have a little issue here, which is that notice that our thumb is aligned. The 0, 0 point of our thumb is the top left, which is that is the origin for all boxes, all things. But really, we want our circular thumb to be centered on the end of that line, right? We don't want the thumb. We don't want the top left of the thumb image to touch the end of the line. We want the center of the thumb to touch the end of the line. There's a pretty easy way to deal with this. We will introduce a fractional offset, or maybe a fractional translation. I think it's fractional translation. We will move our thumb negative 50% in both directions. Notice that our icon is now essentially halfway off screen, but that's what we want because now the center of our thumb is sitting directly above the end of that line. So that actually is what we want. The real problem that we have here is that we're starting our anchor position and our thumb position at 0, and that means the upper left of the screen. We really don't want to do that. We still want to begin at the center. The problem is we no longer know where the center is. We don't know the size of the screen, therefore we don't know. Well, we could look up the size of the screen, but let's be a little more general than that. If this widget was not the size of the screen, the point is we don't know the size of the widget. Therefore, what we need to do is wait until we know what the size of the widget is and then initially pick the anchor position. Here's how we're going to do that. I mentioned a moment ago that I was going to come back up, and instead of having an anchor position at 0, I was just going to let it be null. If that's all we did, we have a problem. Actually, I guess because, well, if we hot restart, we should see the problem. Yeah, so we expect it to be non-null. So you see this error here because it is null. On its own, that's a problem. But here's why we're going to nullify it. In our build method, we're going to say this. We're going to say if the anchor position is null. This means we have yet to calculate the anchor position. Likely this is the very first build call that ever happens. So we don't have an anchor position yet. We don't know the size of our widget. So here's what we're going to do. We're going to access the widget's binding, and we're going to add a post frame callback. This function right here is going to be invoked essentially right after this build method. After this build method, we will know, we can look up the size of our widget. We just can't look it up before the first build. We can look it up after the first build. In this callback, we are going to grab our render box. The render box is the actual kind of runtime representation of our widget. We're going to find the render object. We're going to cast it to a render box because in this case, we know it's going to be a render box. And if that box is not null and it has size, then we're going to set state. We are going to set our anchor position equal to box.size.center, the center of our available space, because we we still want the very first anchor position to be at the center of our widget / the screen. That's exactly what we're calculating here. Now we know the actual size available to us. We're going to place the anchor at the center of the screen. And because this is the very first assignment of an anchor position, we're going to set our thumb position equal to our anchor position. Now, there's one last thing we have to concern ourselves with. We also need to return a widget. Our widget tree down here expects an anchor position, but we don't have one yet. So when this condition is true, when our anchor position is null, we want to return nothing, just a sized box, just a widget to take up some space, and that's it. But after this very first build of this sized box, then this function is going to be invoked. Then as long as we have been laid out by the layout system, we go ahead and assign the very first anchor position to the center of the screen, and we tell the thumb to be exactly the same place as the anchor position. And assuming we got this right, we should be able, well, I guess it immediately jumped there. Let's do a hot restart just to prove that it worked. Hot restart, and there we are at the center. So the first frame goes so fast we don't even notice it. We just immediately see our thumb at the center of the screen. But the very first frame, this is what's happening. Only the first frame. Because the next time we come through here, anchor position is no longer null, so we no longer run this code. This is essentially a one-time adjustment to get us initialized. Now let's see what happens with the springing action though. We can still drag everywhere, but what happens when I let go? Notice that we go back up to the top left. What's going on there? Let's look through our code again. Here's where we define our spring simulations. Notice that our destination is always 0. And that's exactly where we're going. Because we used to have an offset, but now we're using positions. The global position of 0, 0 is the top left. That's not what we want here. We want the anchor position.dx and the anchor position.dy. So now let's drag, and now we have recovered the capability that we want. So we've returned to the exact same behavior that we had, but here's what we've gained. We have completely generalized the concept of an anchor position. Yes, it's still currently at the center of the screen, but it could be anywhere. That's the advantage that we wanted. It could be anywhere. So now let's add a little bit of code to allow us to put it anywhere. Let's define an on tap up method here. I think there's tap up details We'll come back and deal with that in a second. But the reason I put that there is because we're going to come down to our gesture detector where we have our panning. We're also going to listen for on tap up, essentially when the user taps. And that's going to invoke that function up above. Here in on tap up, we're going to call set state and we're going to change the anchor position. And it's going to be equal to the local position of wherever the user just tapped. Let's save that. And it doesn't seem to be doing what I want. Let's do a hot restart and then we're going to start logging this if it still doesn't work. Okay, so let's make sure this is actually getting called. Interesting. Then it moved. Okay, so it is getting called. The local position is what we expect. It changes the anchor position, which is what we want. The question is why the painter is not updating. Because remember, the web painter is supposed to draw a line from the anchor position to the thumb position. And I'm going to guess that the reason it's not doing that is because in the custom painter, I'm telling it to never repaint no matter what. That's probably the source of our issues. Let's go see if that solves it. So let's come down in here to should repaint. And we're taking a web painter. We actually do want to repaint if our anchor position is not equal to the old anchor position or our spring position is not equal to the old spring position. Let's save that. And that was our problem. Notice that as I tap around, the painter is now updating. The painter, wherever I tap, that's the new anchor position, and the thumb is remaining stationary. Now, obviously, this is not entirely the behavior that we want, because every time that I tap a new location, we actually want the spring to, or we want the thumb to spring to the new anchor position. That's the whole goal of this entire thing, is that we want it to spring to that position. If I drag it, notice that if I drag it, it does work. So I can put the anchor here. What this all comes down to is that we don't start springing until we drag. So we need to rethink a little bit when the right time is to spring and when not to. So we'll figure that out and get the truly dynamic anchor position working in the next step. We now allow our anchor position to be moved anywhere on the screen that we want it, but the spring is not automatically updating as we do it. Again, if we tap somewhere, we get a new anchor position, but the thumb just sits wherever it was before. Fortunately, it doesn't take much work on our end to get the behavior that we're looking for here. Let's come up to on tap up, get rid of that print statement. After we change the anchor position, we can there might already be a spring going on, right? So let's end whatever spring might be going on and let's start a new spring. Whenever we tap, we change the anchor position and we essentially cancel whatever existing spring exists and we start a new one. Let's save that. Let's do a hot restart to get back to a known state. And now watch as I tap around the screen. And now we have a two-dimensional, truly dynamic spring. We can have any anchor. We can still drag. And it's two-dimensional. There's still one thing that we want to carry over here, or one adjustment that we want to make. Because the spring moves so quickly, it's a little difficult to see, but there's something that's actually getting reset every time we change the anchor point that shouldn't actually be getting reset. And if you start to do some really interesting things with springs, this will start to rear its head. The thing that we are not preserving is velocity. We we are setting our velocity back to 0 every time we restart our spring. But if we're serious about the spring effect, we want momentum. Again, with this particular spring description, it moves so fast, it's hard to see that velocity goes to 0. And so I'm not going to be able to show you a whole lot of effect when we carry velocity over, but I wanted to call it out, and I'll show you how to easily deal with this. Velocity is also two-dimensional, x and y, so all we have to do is track the previous velocity. Let's come down here to our tick method. And just like we update our thumb position, we can also update our velocity. Because remember, the spring simulation also calculates velocity, except instead of x, we say dx, which means delta x, change in x. And the change in distance is called speed or velocity. Change in position is velocity. Change in distance is speed. So every single frame that we're running a spring, we keep track of that velocity so that we can use the velocity when starting the next spring. But that's not quite all we have to be concerned about. In the case, well, actually, I take that. So I was going to say one thing to keep in mind, at least, is that, let me see where am I? Okay, I was thinking about this. It's at least important to remember that when the simulations are done, the velocity should be 0. Now, the fact that we set it to the simulation's current value actually means that it should naturally become 0 by the end of the simulation. But that's just something to keep in mind as you think about when you start springs and stop springs. You wouldn't want to carry a velocity too far into the future because it shouldn't. You only want to remember the velocity when you're making immediate changes. But with our velocity in hand, we can come back up to start spring. And instead of passing in 0 for velocity, we grab the x and the y values from our previous velocity. Let's save that. Let's see, what are we complaining about? We should probably give it an initial value of 0. And I'll move it up there to be with the position. Okay, and now let's do a hot restart. Okay, there we go. Now you can, if you look very closely, you can kind of see some slight, almost like radial motions, and that's where essentially the momentum or the velocity carries on from the previous move. This particular spring description makes it very difficult to notice that behavior. You have to kind of click in very specific ways, but the velocity is being carried over. We now have a two-dimensional spring system where the anchor position can change at any moment in time. This is essentially the goal we wanted to achieve. So technically we've implemented it. It would be kind of a pain to implement this over and over again if you need this in multiple areas of your project or for different types of spring systems. So we're going to have one final step where we're going to kind of encapsulate and generalize the behavior that we've written so that you can work with the concept of a two-dimensional spring without directly managing two independent spring simulations. So that's the next step, the final step to finish things up. Now that we have a two-dimensional dynamic spring working, it's time to go clean up some of our work. Obviously, if we want to use this capability somewhere else, if all we have is the code that we've written, then we're copying a lot of these methods over to other state objects, other implementations, other projects, when really maybe we don't have to. let's see what we can extract out in the way of an abstraction around the idea of a spring. Let's come down below our state object and let's define a new class. We'll just call it spring. We'd like to move as much of our generic spring capability into this class as possible and therefore offer a kind of standalone two-dimensional spring simulation or animation, however you want to look at it. We know that our solution to this spring problem involves two offsets. We know that there is an anchor position, and we know that there is, at this point, we'll call it a spring position. We called it a thumb position before. Now that we're creating this concept of a spring, let's just call it a spring position. And we want to be able to get and set both of these values. Now, when we set an anchor position, if we happen to be operating a spring simulation right now, we're going to want to end the spring. We haven't defined that yet, but we know that we want to end it so that we can change the anchor position to the new anchor position. And we'll see if this works out, but we probably want to start a spring at that point as well. Maybe, maybe not. Down here for spring position, we also want to be able to get that. Now, if we're changing the spring position, this is kind of like when we're dragging around. Here, we also want to end any spring simulation or effect that's ongoing. Then we will update the new spring position. For this one, we definitely don't want to automatically start springing because as we drag, we're going to change the spring position many times without starting a new spring. So we don't want to automatically do that. We do want a public ability to start a spring. We want a public ability to end a spring. And now we want to start filling in the details here based on the behavior that we've already written. Let's start by essentially just cutting and pasting what we've already implemented, and then we'll massage it to make it work. In fact, we can just take the entire function, start spring, on tick, end spring, and we'll just make start and end public instead of private. End spring will be public. On tick can be private because only we care about the tick. And then start spring will be public. We have a whole bunch of references that aren't resolving now. So we need to go ahead and create local references for things like the spring simulation. All right, so now we have those. The thumb position is going to be replaced by the spring position. Okay, and then we're going to need a spring description, but that's going to be constant. We're going to take that in and it's going to be constant. So we're going to have a final spring description. Okay, that's one more reference down. Now, how about velocity? Now that reference is resolved. And now we get into the stuff around ticker. So what are we going to do here? We're no longer in a state object, so we don't have the single ticker state mixin thing. What we're going to do to resolve that is we're going to bring in a ticker provider. Ticker provider is a class or an interface that allows us to create tickers whenever we want. In fact, the mixin that we used before literally is a ticker provider. When we provide a mixin to animation controllers also are taking in a ticker provider, except animation controllers refer to a ticker provider as a vsync. Okay. So we do still want an individual ticker reference. But the difference is that instead of invoking create ticker as a mixin, we're going to say ticker provider dot create ticker. And we're going to continue to pass our onTick method to the ticker that is created. Now here in onTick, we're going to get rid of set state because we're not in a state object anymore. And now we've pretty much resolved all of our references here. However, the reason we were calling set state previously was so that we could rebuild our user interface. We obviously still need to achieve that somehow. So what we're going to do is come in here up to the class definition, and we're going to mix in change notifier. This is how we're going to notify our listeners whenever something changes. So start spring will probably automatically invoke that on our behalf. Although, I mean, technically, because the moment we change the anchor position, we can go ahead and notify our listeners. When we change the spring position, we can notify our listeners. When we start the spring simulation, nothing in terms of position actually changes here. Instead, it starts the ticking process. So down here in onTick, where we previously had set state, we definitely want to notify listeners at the end of that. And end spring probably doesn't need to notify our listeners. I don't think our listeners need to know when we stop the ticker. That's not publicly relevant. Now, can we use this spring in place of all that code that we wrote in our state object? Let's go integrate it and find out what we're missing, if anything, and see how we can simplify our actual widget code up here. Okay, so you notice that these things are no longer being used. That's because I cut out a bunch of those methods and moved them down into Spring. So we obviously no longer need the Spring simulations, and we no longer need the ticker because we're not controlling those directly from our state object here. We no longer need to worry about previous velocity. Now, thumb position and anchor position are still being referenced here, but they shouldn't be because they're a part of our spring. So we'll figure out how to work that into our spring. We've now removed essentially all of our variables, and we can replace it with just a spring. Because our spring takes in a ticker provider, and remember this mixin right here makes us a ticker provider. What we want to do is instantiate the spring in init state just like we would an animation controller. So spring equals new spring with a ticker provider equal to this and a spring description equal to our spring description. Now we have our spring ready to go. And this needs to be not disposed, needs to be init state. All right, on tap up. What's our goal in on tap up? We want to change our anchor position and we want to start a new simulation. Well, that's easy enough. Let's get rid of all this stuff. And we can say spring dot anchor position equals details.local position. Now I'm having second thoughts about what I said earlier when I said we want to automatically start a spring. We allow the user to drag the spring without starting a simulation, I think we should go ahead and allow the user to change the anchor position without starting a simulation. So instead of automatically doing that, we will manually do it. So first we will change the anchor position, and then we will start a spring simulation. We're giving more granular control. So you can change the anchor position without springing if you want to. It's just not what we want to do. When the user starts dragging, we want to end any spring that might be going on. When the user is dragging and we want to update the spring position, we will say spring position plus equals details.delta. Now we can get rid of what we had before. And then finally, we want to start springing right here. Sure. So that's pretty much all of our user interaction behavior updated to our generic spring. Now let's see what we need to do with our widget tree. I'm going to ignore the initialization for just a moment. We'll come back to that. Let's deal with our web painter. Let's update our anchor position to refer to the spring's anchor position. And then the spring position refers to the spring's spring position. Then down here where we actually position our little thumb icon, let's go with the spring position. And these are just direct, it's the same information, works the same way. We're just referring to the version of the information inside of our new spring object. But now let's talk about this part up here. Anchor position. I don't want to check if anchor position is null. Instead, what I want to do is I want to introduce a Boolean. Is initialized. And what we're going to do is say if not is initialized, then we're going to do this stuff. And once we initialize, obviously we want to set it to true. And one of the reasons we're doing that is, first of all, I don't want our widget tree initialization behavior to depend on some internal policy of the spring object. I want our widget tree to control our widget tree, which is why I've introduced this variable. But also, let's jump back to the spring class for a moment. And I think that the most sane thing to do is to initialize both anchor position and spring position to 0. Clients can change this value immediately if they want to, but let's not even create the possibility that a null value is there. It doesn't do us any good. Okay? So coming back up here to our build method, we have the isInitialized variable. This stuff here with the callback and the render box remains exactly the same. The only thing we need to change here is the assignment of the anchor position and the thumb position. The anchor position is spring.anchor position, and the thumb position is now spring.spring position. And we will set that to the spring.anchor position. Notice that at least all compilation errors are gone. So let's go ahead and save this. Let's do a hot restart. Everything seems to be back. Let's see, so dragging is not, well, actually dragging is working, but visually we don't see anything. And that's because we are not listening for changes to the spring. So here's one way that we can handle that. Every time the spring changes, we set state. Start over again. Okay, now dragging works, but then nothing happens when I release. So let's see what's going on with that. On pan end, we should be starting the spring. We create the simulations. We start ticking. Let's make sure that we're actually getting on tick calls. It looks like we're getting one and only one. And that's so here's what's happening. When we release the spring position starts changing. The spring starts pulling back towards the anchor. At the moment, we are literally invoking this setter method, which immediately calls end spring. That's not what we want. We only want to change the internal data. We do not want to call the public method. So let me see where I'm doing this here. On tick, see, there's no underscore here. But if we add an underscore, then we just directly change the position data, and we don't end the actual spring simulation. Let's save that, do a hot restart, pull it, and now we're springing, and now we get all those ticks. So remove that print statement, save it. And how about changing the anchor position? Changing the anchor position still works. Okay. We still have all the same functionality, but we now have it in this really easy to use package of a spring class. That spring class has an anchor position. It has a spring position. You can tell it to start and you can tell it to end. And that's it. That's all you have to worry about. And it automatically has both dimensions because the anchor position and the spring position are offsets. Now let's go look at how simple our state object is. We have a spring description. We have a spring. We initialize our spring in init state. We give it a ticker provider so that it can do things over time. And we give it the spring description to say what the spring should behave like. We also add a listener to update our UI as the spring changes. When the user taps somewhere, we change the anchor position and we start a spring effect. When the user starts dragging, we stop any ongoing spring. When the user moves the drag position, we move the spring. When the user stops dragging, we start the spring. In our build method, on the very first frame, we figure out where the center of the screen is and we place the anchor and the spring at that location. Then every other frame is this stuff down here. An annotated region to make our status bar light, a gesture detector for drags and taps, a stack so that we can have our background skyscraper image followed by our web painter followed by our actual thumb, and the thumb and the web painter both actually position and paint themselves based on the spring, and we end up with this over here. So I'm thinking that I may even create a more purely physics-based version of this, because even though spring simulation says it's a simulation, it's not really a simulation. It's not based on forces. It's more just pure mathematics. So I might actually create a physics system that allows for like forces like gravity and friction and things like that. We'll see. But this is what we set out to build. I think we've gotten it into a very clean package that does more and is easier to use than what happens to be built into Flutter. So I think it's fair to say that this Flutter challenge is accomplished.